Hello, class. Back with another worked example of an optimization question here. So here we've got a question where, and so here it really helps to have a graph. I've got this point 4, 6. And of course, there are lots of lines through 4, 6. But each of those lines that has negative slope looks something like this. And so that forms a right triangle here. And the question is, what is the minimum area of this triangle? So that is my area, the minimum of this area of this right triangle. That's the thing I'm trying to minimize. So optimize A, and I'll write down a formula for that in a second. But then my constraint is, well, my constraint is given by the fact that I'm choosing a line here, which is really going to give me a restriction on, and I'm going to call this B and this A. So my constraint is going to be a relationship between A and B. Okay. Note, I'll just go ahead and write down here that A is 1/2 A times B. Okay. So I'm going to need to do a little bit of algebra to figure out what the constraint is on how A and B are related. Now, I want to start by writing down the equation of this line in terms of the slope. So this equation of this line is y equals mx plus b. Okay. Now notice, unlike last time I did this, I actually had the foresight to make this b the same as this b, because this is the y-intercept of the line. It's also this side length of this triangle. Great. Okay. But there's actually a relationship here between the slope and b, and that relationship happens because the 0.46 has to be on the line. So here is the phase where we plug in the 0.46, which will give us 6 equals 4m plus b. And so b is 6 minus 4m. Okay, so that tells me this in terms of the slope. I also could have solved this for m, which would have told me the slope in terms of b. The reason I didn't is because then I'd have to divide by 4, and so I'd have fractions running around. So the only reason I didn't do that is because I didn't want there to be fractions running around. Okay, but now we still need to know, what is this little a? Well, this little a, that happens to be where I get this x-intercept. Okay, so this is an x-intercept is at a comma 0. So I need to set this equation, y equals mx plus b, I need to set that equal to 0. So I'm going to get 0 is m times a plus b, but b is 6 minus 4m, so let's say 0 is times a plus 6 minus 4m. Okay, and I need to solve this equation for a, because I wanted to know what a is. Okay, so that's to say m times a is 4m minus 6, which is to say that a is 4 minus 6 over m. Okay, and so these are really my constraints here. They tell me how my a and b, that is the height and width of my triangle, how they're related. And in fact, in this case, we give a relationship between both of them and m, the slope of this line. Okay, so now we are actually ready to solve the problem. Because now what I can do is I can plug both of these into my equation to optimize. So now I get that a is 1/2 times 4 minus 6 over m times 6 minus 4m. And now I can figure out where the derivative of this is 0, and that will tell me what slope I want. And once I know what that slope is, then I can figure out the rest of this information. All right. I'm going to not do the rest of this problem. If you need help with more of it, let me know. But the problems I've been getting about, or the questions I've been getting about these optimization problems have mostly been about figuring out how to set them up. So I'm going to leave you to finish this problem from this point. But for now, until next time, be well.